Okay, we're going to review factoring. So we're going to first start off by reviewing the idea of foiling. First, outer, inner, last. So when we do that, first, outer, inner, last. So you get a smiling little Stewie. So 2x times 4x, first terms, 8x squared. Outside, 2x times 1. Inside, negative 3 times 4x. Last, negative 3 times 1. And the inside terms join together, 8x squared minus 10x minus 3. First, 12x squared. Outer, negative 3xy. Notice we have two variables. That's okay. Inside, now you might want to say yx. We keep the same order, negative 8xy, so that you can tell that they're like terms. And then last, positive 2y. These two are going to join together. Oh, it's going to be y squared, sorry. 12x squared minus 11xy plus 2y squared. And remember, in this case, we could take this out and write it as 2 and FOIL from there, or you can do the shortcut. Shortcut is square the first, multiply and double, because if you FOIL, notice negative 10x. So that's why we multiply and double negative 20x, and then square the last term, plus 4. Whatever way is more comfortable for you, that's fine. First, outer, inner, last, or the shortcut. So always factor out the GCF. The greatest common factor is the largest common term. The first step of factoring is to take out the GCF. So like right here, we look at the numbers, 3 and 6, we can pull out a 3. X squared and x6, we can pull out an x squared. Then it turns into a multiplication problem because we're dividing out. So 3x squared times 1. And negative 6 divided by 3 is 2, and that's going to leave x to the 4th. And you can go back and check it. 3 times 1 is 3, x squared times 1 is x squared. 3x squared times negative 2x to the 4th is 6x, negative 6x to the 6th. So you always go back and verify. Okay, you might want to say, oh, 4. But then there's that 2. So the biggest thing you take out is just a 2. We have m to the third, m to the 1, m to the 1. We always can take out the smallest common exponent, m to the 1. N to the 4, n to the 3, n to the 2. So we're going to take out the smallest common exponent. Now we divide. 4 divided by 2. M3, M1, M2. 3 minus 1 is 2. N4 minus N2 is N squared. Minus 24 divided by 2 is 12. The M1s cancel. N3 minus N2 is N or N to the 1. Plus, you can put the 1 or you don't have to. 2 divided by 2. The M's cancel and the N's cancel. So actually, in this case, I'm sorry, you do have to put the 1. If any of the variables were left, you wouldn't need to, but since there's no variables, you need the 1 as a placeholder and a real value. And again, you could distribute this through and double check it. Well, you try, but I'm here, so let's just do this. So what goes into 36 and 63? 9. What goes in x15 and x12? Smallest one. y10 and y17? y10. z5 and no z? We can't pull out z because it's not common. So 63 divided by 9. 15 minus 12. X cubed. 10 minus 10. That cancels. But the z to the 5th just falls on down. Plus 36 divided by 9. X12s cancel. Y17, Y10, that leaves y to the 7th. Okay, the difference of two squares. This always breaks down to two parentheses. One's going to be plus, one's going to be minus, and then the square root of each term. So, 25, x squared, and 121 are all perfect squares. So, square root of 25, square root of x squared, and the square root of 121. And then we just make 1 plus, 1 minus, and we are done. Now this one doesn't look like a different two squares, because it's not. First step is always to check for the GCF. Now we have perfect squares. Don't forget to bring this 3 down. That's the most common mistake. Again, square root of x squared is x. Square root of 9 is 3. Make 1 plus, 1 minus, and you're finished. This one's a little trickier because you got the extra y, but that's okay. Square root of 4, 2. Square root of x squared, x. Square root of 81, 9. Square root of y squared, y. 1 plus, 1 minus, that's it. Okay, the sum of two squares. That's x squared plus y squared. And this is going to be based off the same thing we just did, except now we need to bring in our friend, the imaginary number. Square root of x squared, square root of y squared. It's still going to be 1 plus, 1 minus, but we're going to need our old friend y in there. So, square root of 36, square root of x, square root of 1, and we just throw in our I, 1 plus, 1 minus. That's it. It's really that simple. It's the same as the difference of two squares, you just throw the I in there. Okay, x squared plus 49. Again, perfect squares. Square root of x squared, square root of 49. We throw an I on the end, make 1 plus, 1 minus, and it works out. Let me show you why it works out. If I FOIL this, I get x squared. And then I get minus 7xi plus 7xi. These are going to cancel out. Minus 49i squared. Let me clean that up. Minus 49i squared. You say, well, wait a minute. That's a minus, it's supposed to be plus. Hold on. Remember that the I squared is really negative 1. So what does that do to this? It makes it positive. That's why it works out. So it works just the same as difference of two squares, except we add 9. Okay? Factor out 2. 25x squared plus 9. Now I have a sum of two squares. Keep the 2, 2 parentheses, 1 plus, 1 minus. Square root of 25, square root of x squared, square root of 9. And the only thing I need to do is the sum